And as we said today, we are going to do 10.1. We're going to do 10.3. We cover 10.1. We just cover 10.2, which is again the concave up and down a point of view. 10.3 is almost using what we learned in 10.1, especially how to find the relative maximum, minimum, concave up and down, and also point of inflection. We are going to apply those techniques on a business and economics application. Again, this course is a business calculus, so most of the application problems in the textbook, they are only related to business and economics. So we are not going to cover a new topic here, but basically we are going to use the application of, as we can see, absolute maximum and minimum is almost the same as relative maximum and minimum. But what happens is that if you have a function and the function have, let's say, a parabola, but it have let's say a regular function, but the curves are like 4. What I mean by 4 is that the curves increase, the function increase and decrease again, increase and decrease again. In this case, we are going to have 2 relative maximum and 2 relative minima, because anywhere the curve increase and decrease is called a relative maximum. Anywhere it decrease and increase is called relative minimum. Now, absolute maximum is a little bit different from relative. Absolute maximum means even the curve have, we have 4 curves on the graph, which means we have 2 relative maximum and 2 relative minimum, but the absolute maximum and minimum will be only 1. So if I have 2 relative maximum, the highest one, the highest maximum, the longest one is called the absolute maximum. So even if we have a function or a graph that curve more than 20 times, we still have only 1 absolute maximum and 1 absolute minimum, not more than 1. It's only 1. So that's the difference. But the process of finding it is almost again the same. So we will go through that. So after that, then we are going to solve some business application problems. For example, how to maximize a revenue if a total revenue function is given. This means our aim will be the absolute maximum, because absolute maximum is the highest point from increase to decrease. Also, how to minimize the average cost given the total cost function. We want to minimize it, so we're looking for the most minimum. So the concept will be absolute minima. We find the absolute minima of the average cost function, and that will give us the minimize the most minimal cost, average cost. Also, we're going to learn how to find the maximum profit from total cost and total revenue function. So this concept we did once before. Even if the profit function is not given, but they give us the revenue and the total cost, we know profit is equal to revenue minus total cost. Then when we get the profit function, here we are looking for the maximum profit. Then we are going to use the concept of finding the absolute maximum of the profit function. So let's start. So first we start with the definition of absolute extrema. And again, we said it's almost the same as relative extrema, but the difference is that in a relative extrema, we can have more than 1 relative maxima, more than 1 relative minima. Anyway, we have increasing to decreasing, we have 1 of them. Decrease to increasing, we have 1 of them. But with absolute extrema, we are looking for the most highest or most lowest. Actually, that's what the keyword absolute means. Absolute maximum, the most highest, the most maximum, and or the most minimum. So here we say that absolute extrema are function values that are the largest. Again, that's the keyword. I may have 2 relative maximum, but the largest one should be the absolute maximum. or the smallest value if it's minimum, the lowest or the smallest, over the whole domain of the function, the entire domain of the function. So even if we have 100 curves, again, we're going to have only one absolute minimum and maximum. So the definition here is almost the same as relative maximum and minimum. The difference is that, again, absolute means the highest or the largest, maximum, lowest, absolute, minimum. So we can see that if the function, so here we can say that if the function f at a is, if the function f at a is greater than or equal to f at x for all the x in the domain of the function over an interval of interest. Here we say for the all x in the domain of the function. So we're just looking for the one great A, the greatest A. Then this will give us the absolute maximum. And it will be opposite. If we have B, f at B, and it's less than or equal to f at x for all the x domain, then we have the point B will be our absolute minimum. So again, absolute maximum and minimum, no matter how many increasing and decreasing curves we have in the function, we only get two values, the most maximum and the most minimum. So if we have this function, again, this function have only one, a parabola. So here we have the point at 1 will still be the relative minimum, and also it will be the absolute minimum because it's only one curve. Now, if we have two turning points, then we look for the lowest among the two. So here they say we should consider the following graph y equal to s minus s squared. The graph have a relative minimum at 1 and 0. So this is a relative minimum. But since we have only one increasing to decreasing, we have only one relative minima, which is a point of decreasing to increasing. That point also will be the relative, it's relative minimum. So it's also going to be the absolute minimum also. So here they say we should note that relative minimum is the lowest point on the graph. And as we said, in this case, we have only 1 point lowest in the graph. So it's still an absolute minimum point also. Similarly, if we have another graph, okay, let's use this example here. If we have this graph here, I thought somebody entered right here. Okay, so if we have another graph, let's say this graph here, we can tell where the relative, here we have only relative minimum at 1 again, but the point shows where the graph ends. So my absolute minimum can be 1 at the point 1 minimum. The absolute maximum, we can say at the highest point of the graph, but this is not a relative. This is not a relative, how will I say, relative maximum, because relative maximum means from increasing to decreasing. But absolute maximum means the highest point in the graph at the top. So here we say that if the domain of this function is restricted from half to 2, so the lower, the first point here is half, and to the right point is 2. Then we get a graph shown below, which is this graph. So we say in this case, there is an absolute maximum at 0.1. No, sorry. There's an absolute maximum of 1 at 0.2 and 1. So the maximum is right here. as we said, the 0.2, because absolute maximum, we don't take the condition of from increasing to decreasing. We don't do that. We only do that for relative maximum, the highest point where we curve. But here we are looking for the highest point in the graph or the lowest point in the graph. Now, if this graph should have gone down a little bit, then we will say that the absolute minima will be, let's say the y is less than 0. Then we will say the point is there. So that's the whole concept in the theory. Again, we're going to solve a problem in a few minutes. So I'll wait for a few seconds if it's okay. Absolute, in this case, again, the absolute minimum, the lowest point in the graph is 1. X is 1, Y is 0. The highest point in the graph, S is 2, Y is 1. So that will be the absolute maximum. Now we have a function here. This function is y equal to s minus 1 square again, but it's restricted to the only interval between 2 and 3. So we can see the first point down, 2 and 3. So in this case, the absolute minimum is 1. So you can see here, if it's we cannot say relative minimum is 1, because relative minimum gives us the condition where the function decrease to increasing, relative minimum, where the curve, it curves from changing from again decreasing to increasing. But absolute minimum is just the minimum point in the graph when we consider y. See, the lowest point for y is when x is 2, y is 1. The highest will be when x is 3, y is somewhere around 4. So that will be the absolute maximum, then absolute minimum. So again, let's go straight for an example, then hopefully that may help us. So yeah, we have a function, a revenue function, how to maximize a revenue. So again, I'm not going to read all the question, but a question is given, and we know the total revenue function is r at x equal to 16x minus 0.02 x squared. Now, the point where the first derivative of r at x equal to 0 is clearly the maximum, because r at x is parabola that points downward. Because we can see the highest point degree is x squared. So anytime we have a function that the highest degree of the variable is square, it will be a parabola shape. And also, since the coefficient of the x square is negative, it's going to open again downward. So this means if a parabola open downward, we are going to get the absolute maximum or even relative maximum also. Open downward means from increasing to decreasing. So we have relative maximum also. So let's say the question, I think it should be solved somewhere. Well, let's go back and maybe this is just, so we have 16x squared minus 0.02x squared. So the first thing we have to look for is the first derivative of this function, which will give us to give us 16 minus 0.02x. Then from there, we equate it to 0. Then we look for the value of x. Then later we put the x into the original function. Then we find the y. So that point will give it the absolute maximum point. So we can say that the step of solving it is almost the same as looking for the relative maximum. But with relative maximum, because relative maximum means we want to know the point where the graph increase to decreasing. So we have to test the interval. We want to see the interval where it's increasing, the interval where it's decreasing after we get the critical point. So if it works from positive to negative, then we say that's the relative maximum at the critical point. But with absolute maximum, we don't care whether the function is increasing or decreasing, as we saw the earlier time. So it's more quicker here. We are not going to test if this function is increasing or decreasing, because even at the point here, there's no continuation to decreasing. So it can go higher more. But this is based on the domain. The domain is 3. Maybe if the domain of the S is up to 4, maybe the absolute maximum will go up more, maybe. So when we are looking for absolute maximum or minimum, it's more quicker because we don't need to find the interval where the function is increasing and decreasing. But with relative, you have to find, because relative maximum means the point, the highest point, and the point where the function changes from increasing to decreasing. Relative minimum is the point where the function changes from decreasing to increasing. So as we said earlier, if you have a function with many curves, let's say 10 curves, there's a possibility that we can get more than one relative minimum and also relative maximum. But with absolute, again, absolute maximum or minimum, we only get one value each, because we are just looking, we are not looking for where the function increasing and decreasing or decreasing and increasing. We are not looking for that point. We are looking for the highest and the lowest point in the graph. So in this graph here, the lowest point is our dot below the starting of the graph. The highest point will be the end of the graph, the top. So that will be the absolute maximum, and the downward will be the relative maximum. So you can see the steps here are very, very quicker than the 10.1 we studied the relative maximum. Again, the explanation is all here. We have this function, 16x minus 0.02x squared. They say we should find, in this case, I can also find the absolute minimum. You see, if I have this function and they say I should find the relative minimum, there's no relative minimum. There is none. We all agree, because this function open downward, because the coefficient of x squared is negative. So it's going to open downward. If it's positive, it will open upward. And this means we don't have no relative maximum. But in this function here, if I'm looking for the absolute, I can get the absolute minimum and absolute minimum, because maximum, because every function, whether linear, log, exponential function, you always get the starting point, the lowest point in the graph, and you will get the highest point in the graph. Always. In the graph you graph, linear, whether straight line graph, there's a lowest and the highest point. But in a linear curve or a linear straight line graph, there's no relative minimum. There's no relative maximum, because it goes straight. It doesn't turn. But in a linear curve, I can find the absolute maximum and minimum, because the lowest and the highest point. So that's the only thing I want us to understand here. Now, the steps to find the absolute maximum and minimum. The revenue function here is given. The first thing I'll do, find the first derivative of the function. Then equate it to 0. It's same as finding the critical value. When we get the critical value, we're going to plug the critical value into the original function. And that will be our absolute point, or whether maximum, minimum, the absolute points. Then later we test. Again, let's see if we can get a very good example here. So here the same question, the increase, the numbers in the group, price per person. We'll see that as the conditions increase, revenue is changing. It will reach some stage, it will be highest. Maybe the more people we have in the group, or the price per person, it will reach some stage that it won't go high no more, but rather it will start to reduce. Again, I want us to see a nice question then. Let me see. Okay, so only one example. So let's go to this example then. Let's start from beginning of the example. Hopefully we get it. So yeah, they say that because the marginal revenue, again, marginal revenue will be the derivative revenue, is the first derivative of the total revenue. it should be obvious that the total revenue function will have a critical point at the point where the marginal revenue equal to 0. So this means we find the marginal revenue, which is the first derivative of the function. Then we equate the function to 0. And this clearly will be the maximum because what R at X is parabola that open downward. So if it open downward, it will curve, go up, down. That means we have a maximum point there. But the domain may be limited. So it depends on the domain of the function. As we saw the previous function, the domain in the X, that's the X interval, can change, and that can have effect on the absolute values, both the minimum and maximum. So, but the domain may be limited. The revenue function may not always be a parabola, or a critical point may not always be the maximum. So here they say it's very important that the way the maximum values occurs. But before that, let's go up. We can see that this function is square. So it's supposed to be a parabola, but we are taking the domain of 2 to 3. So 2 to 3 look like almost a linear curve. It's kind of like a linear curve for exponential. I would say exponential curve increasing fast. But this function shouldn't be an exponential function. It should rather be a parabola. But because of the domain. So if the domain should be, let's say, from -1 to, or let's say -4 to +4, maybe we will see the shape of the whole parabola. So that's what they are saying, that the domain also can have effect on the maximum value. So if no question here, again, the step here they are trying to explain to us, we find the first derivative of the function, revenue function. We equate it to 0, then we find the X, and that will be our critical value. And based on the domain of the function, this may be a parabola or it may not be a parabola because some part of the X interval may be cut off based on the domain. So now the question said that if a travel agency will plan a tours for a group of 25 or larger, but we have a condition here. We have a groups of 25 or larger. Now, if the group contains exactly 25 people, then the price is 300 per person. Now, if they have more than that, however, the price per person is reduced by 10 for each additional person above 25. So which means if we have only 10 people, each one will be $25. The amount is for $300. To be $300. If we have up to 25, each person pay 300. Now, if we have 26, the additional one person will be paying $10. So if we have 30, the last 5 people will pay $10. Now, the question now, we want to maximize our profit. So the question says, what size group produce the largest revenue for the agent? The larger revenue we have, maybe the more profit we get. So this is the whole concept of optimization problem. So we are trying to find the maximum point based on the number of persons. So here we say the total revenue is what? The number of people, then the price per person. But we know that the number of people, if it's 25, up to 25, let's say the number of people will be X. The price is 300. The condition said if it's up to 25, then it will be 300 times X. If only X is 25 or less. But if X is more than 25, then we're going to have the first 25 times 300 plus the rest will be 10. X, whether it's whatever amount of X, so it will be 10X. 10X is when the X is greater than 25. So that's the condition we have in the table here. The number in the group is 25. Okay, that's perfect. Each person is 300 then. 25 times 300 will give us 7,500. Now, the number in the group is 25 and extra 1. So this means we cut it down, 300 minus 10. So that will give us 7540. Then if it's 2, it will be minus 20 all the way. So we say 25 plus x, then it will be 300 minus 10x, which means our first 25 is where each one per person is 300. But now plus x, if we have extra 1, 2, 3 after 25, it will be 10x. It's the additional 10x. So that means our revenue function will be 25 plus x, which means we have more than 25 people. If it's 25 plus x, the first 25, 300, x will be 10 each. So if x is 2, it will be minus 10 times 2. If it's 20, minus 10 times 20. So this will be our revenue function based on the condition given to us. So I'll wait for a few seconds if it's okay. Okay. So we have the revenue function R at x will give me 25 plus x, 300 minus 10x. Open the multiply the two together. This will be the number of persons times the price. And that gives us 7,500 plus 50x minus 10x squared. So yeah, we say the critical value. So we have to find the derivative, the marginal revenue. Then the answer we get, we equate it to 0. So the marginal revenue, the derivative will be 50 minus 20x. Why? Because derivative of a constant value is 0. So 7,500 will be 0. Derivative of 50x will be 50. Derivative of minus 10x squared will be minus 20x. So we get minus 20x plus 50, or 50 minus 20x. Then we equate the solution, the first derivative to 0. So this is what we get. And if we have 0 equal to 50 minus 20x, x will give us 2.5. So 2.5 is our critical value. This means adding 2.5 people to the group will maximize the total revenue. So roughly we will say 3 people or 2 people between 2, but we cannot add half a person. So we will test the total revenue function with 27 first, then we test it with 28, and we see which one have the maximum revenue. So we can see what I mentioned earlier also is that we can say that finding the absolute maximum and minimum is more shorter than relative, because in relative, when we get the critical value, we need to go and test the interval where positive means the function increasing, negative means the function is decreasing. So if we have a critical value and we test the value to the left of the critical value, any value less than the critical value, and the function is increasing, we test the right section also, the function is increasing. That means that critical value is not a relative point. It's not either relative maximum or minimum, because increasing to increasing or decreasing to decreasing, this can be a point of inflection if you find the second degree. But with maximum, absolute maximum and minimum, we don't need to test any interval. We just want to find a critical value, and always the critical value will give us, in this case, the function is parabola open downward. So we are looking for that point of critical value will be our maximum point. So when we test with that, since we have 2.5, we test with 27, because 25 is already 25 means they pay 300 per person. Additional one, they will pay 10. So we test with 2, 27, we get 75.60. And we test with 3, we get the same value. It seems like the same value. Yeah. 75.60 for 2, and 75.60 also for 3. So we should note that both 25 and 28 people give the same total revenue. And that is a revenue is greater than revenue for 25 people. 25 people will give us 7,500, but 27 and 28 will give us 75.60. So we can see the graph here. 2.5 is between 25 and 28. 2.5 between 2 and 3 again. So that will be our, again, absolute maximum point. So wait for a few seconds. If any question, then we do one more example for minimize. Okay. So how do we minimize? Again, the process is the same. So here, first of all, we're going to find the minimal point. Then later, we can also find the average cost. So the formula for average cost is like finding the average of something. So if I have a total cost to be C at X, and S is the number of units, then what will I do? Anytime I'm finding the average of something, I will add everything, then I'll divide by the number of items. So that's the formula here. And some of you take statistics. We normally sample mean, we always use the bar. So this is like finding the sample mean, which is called total cost function. So it will be the total cost divided by the number of items we have. X represent the number of items that we are finding the total cost for. And this will be the average cost. So now we have example here. They said if the total cost function for a commodity is given as the formula here, 1/4 x squared plus 4x plus $100. The X represent the number of units produced. So producing how many units will result in a minimum average cost per unit. So the first thing we're going to find is the minimum average cost per 1 unit. Then the next, they say we should find the minimum average cost. So we know the function is given. So if I have the total cost to be this, first I'm going to find the average cost. Again, in statistics, average cost or average of anything is the total of that of anything divided by the number of the things we have or anything. So here we have the total cost. S is the number of items. So we divide the total cost by the number of items, which is X. So now here we are looking, we found the average, because here they say we should find the minimum average cost. So the first thing we need to find the average cost function. This is a total cost function. So we cannot use the total cost function to find the minimum, absolute minimum. We have to find the average cost function. And in statistics, we know to find the average of anything, you find the sum of the things and you divide by the number of the things you have. And that's what we did here. So this means average total cost function will be 1/4 X plus 4 plus 100 over X. So if no question, let's keep going. So we have the average cost. We are looking for the, I would say absolute minimum, but we are looking for the minimum average cost, which is the same as again, absolute minimum. So we have, again, let's go back. Hopefully everybody understands. So I want to go through how we got the derivative of the function. 1/4 x, the derivative of this function, we leave the constant value alone. Derivative of x will be 1. So 1/4 x will give us 1/4. Derivative of 4 will be 0. X here will go up, it will be x raised to the power -1. So derivative of 100 times x raised to the power -1 will be -100, because -1 times 100 will be -100. So -100 x to the power -1 minus 1, which will give us -2. Now I will bring the x down and change the -2 to +2. So that's why we got x plus 1/4 minus, because we have -100. S to the power -2, we bring the 2 down, so we have s positive now. So that's the derivative of the function. So we know the steps now. We have to equate this to 0. So we equate the function, the first derivative of the average cost, to 0. Again, the question said we should look for the average minimal cost. If the function said we should look for the minimal cost, like, we can use the cost function. But because they say we should look for the average minimal cost, first we find the average function, then we find the first derivative of the average function, then we equate it to 0, then we get the critical value. Same steps as finding the absolute maximum and minimum, they are the same step. So when we equate it to 0, this is what we get. S is equal to ±20. But remember, this question is a business question. The number of products that we produce can never be a negative value. So we are going to ignore -20. If the company didn't produce anything, we get S will be 0. If they produce something, it will be a positive value, 1 or more. So -20 will be gone. So here we are going to use only 20. So here we say because the quantity produced must be positive, 20 units, if we produce 20 units, that will minimize the average cost per unit. So that's it. So here we show that it is an absolute minimum by using the second derivative. Here we are trying to check it. So we find the second derivative of the function, and this is what we get. And the second derivative of the function, the x should be greater than 0. When s is greater than 0, the second derivative of the function will be greater than 0 based on the domain. When s is greater than 0. So the average cost per unit occurs if 20 units, the minimum average cost. We don't need to do this. We already have the answer here, but here we just check. When we find the first derivative, I equate it to 0. The x value that I get, that will be my x, the number of items I can produce. That will give me the minimum average cost, and that's +20. We are not going to use the negative again. Here we are producing products. So we can see the function. This is the cost function if we plot it in our calculator. And we can see that at 0.20, that's where we have the average, the most minimal cost to the left, the y value. The most minimal y value is 14. And that is the most minimal in the graph. We can see after 14, the graph is going up a little bit all the way. Then we have another function, 1/4. This is the first one we did. And this is the function, the original cost function. I'll wait for a few seconds if any question. Again, finding the absolute minimum and maximum value It's all we focus on is how to find a critical value. When you get that critical value, based on the equation given to us, we can know if our value is minimum or maximum.
Professor?
Yes.
How does negative 100 over x squared go to 200 over x cubed?
Yeah, we find the second derivative. So let's go back to the first derivative of the function. This is the first derivative of the function. So if I want to find the second derivative of this function, 1/4 will be what? 0. Then I'm going to get x squared. I will take the x squared up. So I'll get x to the power -2. Now, -2 times -100 will give me what? +200. Then the derivative of x to the power -2, it will be -2, -1. So -2, -1 will give me -3. So the top will be s raised to the power -3 times +200, because we have -2 times -100. So the negative sign here will change to positive. Now, since we have +200 s to the power -3, we can bring the x to the power -3 down, and it will be +3. So that's why we got 200 divided by s cubed. The whole concept is that you are finding the derivative. So again, as we said, we should very, very get used to the derivative rules that we went through in chapter 9. Here we are applying the power rule here. The first is constant rule. Derivative of 1/4 is 0. Derivative of, this is power rule because s squared, I can bring it up and it will be s to the power -2. So the power rule said I should multiply the exponent with the coefficient here. So I'll multiply -2 with -100. That will give me +200. Then they say the power rule said we should subtract 1 from the exponent. We have s to the power -2. So we subtract 1. -2, -1 will give me -3. So actually the answer here should be 200 times s to the power -3. But you can change the -3 to +3 by bringing the x down. So that's why we got this.
Thank
I
you.
hope I answer your question or you understand what I mean here.
I understand.
Yeah, it's just looking for the second derivative of the function. So I'll wait for a few seconds more if we have question. Okay. So again, this section is just the explanation of the graph. I'm going to skip all this. Again, it's just, you can read through. Again, if you have the textbook, also it's the same example from the textbook. I'm using the slides that came with the textbook. So it's the same. The textbook explain all this. So the next one is maximize profit. Again, is the same as maximize revenue. The name just changed to profit. I have for example, here most of the time in the textbook questions, if they say we should maximize a profit, they will not give you the profit function. They will give you the revenue function and also the total cost function. But we know that in business, the total revenue minus total cost will be my total profit. So if the revenue and the cost functions are given, I can find the profit function. Other than that, then they will give us the profit function. Then the step again, as I said, is the same. We are looking for absolute maximum because to maximize the profit. So here we are using MP. MP stands for marginal profit. As we said in chapter 9, anytime we see the keyword marginal, it means we are looking for the first derivative of P. So NP, marginal profit, means first derivative of P. And here we have a bar. The bar at the top in statistics, we use it for the sample mean. The same thing we are using it here for. The bar here means the average profit. So here we are looking for the average marginal profit is always equal to the first derivative of the profit. First derivative of the profit. So marginal means first derivative. So here they told us we have already seen how to use the derivative to find the maximum and minimum for various functions. We find the total cost and the total revenue. Now we can also apply those same techniques in the context of profit maximization. So we can use marginal profit to maximize profit functions. So if this question is good, they give us straight the profit function. But as I said earlier again, we may have there's so many, we will see a homework assignment on these topics, hopefully next 2 weeks. I'll post it this weekend, then it will due the following week again. I try to make everything 1 week ahead so you have enough time to study. But you will see some questions in the homework. They will give you the revenue function and the total cost function. You have to find the profit function. Then later you find the marginal profit. Then you find the number of units you have to again sell or in order to get a profit, to maximize your profit, the highest profit you can get. So here they give us the function straight. This is the profit function. Now the question here is that how many X units, the number of units we can sell is X, that we can sell, and that will give us the maximum profit. So again, the same step. Here we don't need to find any average because we don't even know the number of units already. So here we have to, normally we use the average for total cost because sometimes they give us total cost of items and they say we should find the average, minimum average cost. So I'll divide the X. If X is the variable we use for the number of items, I'll divide by the total cost function and I'll get the average cost function. Then I'll find the first derivative. Then I'll equate it to 0. Then I'll find the X value. And that will lead us to the minimum total average cost. The same process here. We find the first derivative of this function. So it's giving, actually, let's go through how we got the answer. So the first derivative here will be 4 times 3. Then 3 minus 1 for the exponent. So here we get 12x squared. Here we have 2 times 2, 10. So that will give us 420. And then 2 minus 1, that will give us 1. So we get minus 420x. Here x is 1. So 1 minus 1 is 0. Any variable value, anything raised to the power 0 is 1. So s raised to the power 0 is 1. So that's why the derivative of 3600x will be 3600. Then derivative of any constant value is 0. So that's why we have 12x squared minus 420x plus 3600. Now we have to equate this to 0, then we solve the equation. So we said we factorize this equation again. The steps here is pre-calculus. 12 is common among all the 3 terms, so we bring 12 out. Then you are going to get a trinomial with x squared. So we use the techniques of a trinomial with x squared. You have x and x, which is x squared. Find the 2 values. When you multiply, you get plus 3600. When you combine, you get minus 420. And that was 15 and 20. Negative 15 times negative 20 will give me 3600. Then you combine the term, will give me this. Actually, I'm making a mistake here, but I'm just trying to explain because I didn't. First of all, 12 is common in all. So 12 into 420, I think that will give us, somebody can do it very quick for us, to give us around 15 or 16 or something. So when you factorize the common 12 out, then whatever left with these two, that is these 2 values here. So I know that the middle here, it will give me negative 45. So because if I combine negative 15 and no, sorry, 35. If I combine negative 15 and negative 20, that will give me 35. So this will be negative 35, which means 12 can go into 420 is 35 left. And if I multiply these two, I'll get, I think, 600, 300, 300. Yeah, 300. So 12 can go into 3600 will be 300. So actually the equation will be x squared minus 35x plus 300. Then you find the two numbers. When you multiply, you get plus 300. When you combine, you get minus 35. And that's what they did here. So here we know that we are dealing with products. 12 will be gone. 12 equal to 0, 0. So s minus 15 will give me positive. S minus 15 equal to 0 will give me positive 15. S minus 20 equal to 0 give me. So here we get two positive values. So we have to be careful. We get 15 and 20. So we have to know which one. Either if we sell 15 items, we will get the maximum profit, or if we sell 20 items, we will get the maximum profit. If one of them should be negative, like we will cancel it out. We don't need to. So yeah, we have to check both. So we check for 15 and then 20. And that's what they came up here with. We want to maximum increase our profit. So it will be this. This is reduce. So from positive to negative is this. This is like finding the relative maximum and minimum, because we have 2 points. We want to check both. So in conclusion, we will say that 15, when S is 50, the number of units sold is 15. We get a profit of 20,050. And that will be our relative maximum. And we check the endpoints 0 to 30. Here we are looking for the intervals before we're going to decide which one is the absolute maximum. So if we check with 0, plug 0 into the P, you get negative 200. It's not good. Plug 30 into the P, you get 26,800. Actually, that's the highest. So it's greater than 15. It's greater because the interval, the domain is from 20 to 30, which should be based on the question. Yeah, the question you can see here. They say the restrictions on the capacity should be between 0 to 30. So when I get the critical value and I check the two values, the second one I don't need to check because 20, I saw that it's going down too much. So that one is out. 15 give me up, so I'll keep the 15 for now. So now let me check the endpoint, 0 and 30, because that's the question give us the interval. The maximum we can sell is up to 30. Or sometimes we may not sell anything, maybe we can make more profit. So we start from 0. So when we check with 0, we find out that we are not going to, we are going to lose rather, it's minus 2, we're going to lose $200. But when we sell 30 items, we get 26,800. Okay, so we can't use the 15. 15 is too small, 20. So the maximum, now we cannot, maybe 31 can be more. 32 will be more. But again, the reason why we are using 30, I'll go back to the question. The question says from 0 to 30. So you can't go more than 30. They gave us the domain, the restriction on the capacity is between 0 to 30. So 30 gave us the highest. So that will be our, again, the number of items we can sell. And we can see the graph here. We can see that at 30, even we can see the graph is increasing going. So at 31, 32 will be more profit. But again, the restriction is up to 30. So we check up to 30. So this is just an explanation of average cost. And also we told you about the formula also. If I have P at X, it can be P at S minus the average cost. Always we have to subtract at cost. The P here represents the demand function, the demand that we need. A function will be given for the demand. And we need to find the average cost per unit. When we subtract the two, we get our profit. Sometimes also revenue may be given. If a revenue is given, we still subtract the cost from the revenue and we still get the profit also. So revenue is always the price. So the P will be the price and X will be the number of units. And that will be the conclusion. So I'm going again, we still have, my computer say 9:38. So we still have like 7 minutes. We cannot start a new topic. So again, this is 10.3. So next week, hopefully, we're going to cover 10.4. And we have next week, surely we're going to finish. Normally next week, I normally give the midterm in week 7 because that's the halfway. But our midterm will be in week 8 because the midterm should be conclusion of chapter 10. We have to finish chapter 10. So we still have only 2 seconds. Let me make sure. So next week we'll go through 10.4. 10.4 is application of maxima and minima. Then we also, so you will see I'm going to post the video of that in week 7. You'll see both videos. Also application of Morse curve sketching, relational functions. There's some few application of derivative. And I think that's it.
Professor, I have a question.
Yeah, go ahead, please.
I was a little confused. I thought the due date for week 4 assignment got pushed back to today.
Yeah, so you can submit it today.
Okay, cool.
Yeah, I didn't give anybody no 0. If you submit it, I grade it if I have a time. After today, that's when maybe from tomorrow, if you don't submit it, then I'll put 0. But so far, if you didn't submit it, you'll see that your grade is open. There's nothing in your grade. Or if I put 0, then it's by mistake. I will take it off. So I quite remember I mentioned that the week 4 is supposed to be due on Tuesday, but I extended it to today.
Okay, thank you so much.
Okay. So I think that will be then in chapter 11. After the midterm, we're going to do the derivative of log functions. And also, let me see, log function. Then the next will be a exponential function. I think this will be in week 8 on Thursday. So we are looking at our midterm will be hopefully it will be next 2 weeks Tuesday. Then Thursday we start chapter. That's next 2 weeks. Next week we do 10.4, 10.5, and the review for the midterm. And the review for midterm for next week, Tuesday and Thursday. Then we do again. Like I would like us to do the midterm in class, but I have to find out from the school first. Our classroom, they say we can only have up to 10 students the first time, I was told. I think our room is 218 in business departments, exchange place, campus. But I will find out if we can have a larger room to do the midterm in class. That would be perfect because in this case, we need to test our students, make sure they are following the materials is okay. But if it's not possible, then we take it online as we did with the quiz. So I will send an email hopefully to the chairperson within the week or next week to verify that. So if you don't hear from me, that means we are going to have the midterm online. Even if I come to campus next week, not everybody can be inside the room. The room take only 10 people. And we have like 26 or 25 students in this class. Even today, we have 18 attendance right now. So 18 cannot go into that room because we still have to practice the social distance. So for now, let's assume the midterm will be online. Then if I don't send no email, then the meeting will be online as we did the quiz. But if I send an email that the meeting will be in class, that means they gave us a bigger room whereby at least 25 students can go in together with no social distance problem.
Professor?
Okay. Yeah, go ahead.
So when are we gonna have the midterm? After our spring break or before?
Oh, even see, I'm talking, I don't even look my calendar when it's a spring break. When is the spring break? Is it next 2 weeks?
It's the first like full week of March, so I think that's like the week of March 8th.
Okay, so I will check and see. That means, like, I was thinking next week we are going to finish 10.4 and then 10.5. Then next 2 weeks on Tuesday, we're going to have a midterm. It seems like next 2 weeks will be the spring break. I'll check my academic, the calendar. So if that's the
Yeah, because
case,
2 weeks from today would be spring break.
yes, then we're going to have the midterm after spring break. For
On the
sure.
Tuesday or on the Thursday?
It will be Tuesday.
Okay.
Yeah, because we're still going to finish the review next week, Thursday. So if we finish next week, Thursday, for midterm review, next 2 weeks is a spring break. Then we go to spring break. When we come on Tuesday, that's 3 weeks from now, then we have the midterm then. So I will post the announcement in the classroom, in the blackboard, and I'll check the calendar very well to make sure. Okay, so if no other question, then I'm going to stop the recording, and I wish everybody a good day, and we